Good morning and happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, today we're going to go on and cover section or objective 5B, which is something called scientific notation. Scientific notation comes into play when we're dealing with extremely large numbers that maybe have several non-zero digits followed by a whole bunch of zeros, or extremely small numbers where we have a decimal point, a bunch of zeros, and then some non-zero digits. It's a way of writing it in a certain form that doesn't always take up as much room. Now, scientific notation or scientific form, as it's sometimes called, has two parts. One part is a decimal number that has exactly one non-zero digit to the left of the decimal point. For instance, 2.13, 7.85, 4.002. Those are all in scientific notation. There is a second part of scientific notation, and that is a power of 10. For instance, this first one might be 2.13 times 10 to the fourth power, 7.85 times 10 to the 12th power, 4.002 times 10 to the negative third power. Scientific notation is one place where two things happen that not necessarily happen other places in algebra. One, we go back to using an x as a multiplication symbol rather than as a variable in this context. Two, we might have an answer that has a negative exponent and we leave it as a negative exponent, but it's always a power of 10. So scientific notation has two parts. The first part is a decimal number with exactly one non-zero digit to the left of the decimal point times a power of 10. Let's take a look at how that plays out. Let's say we have the following number, 35,800,000. Okay, and we want to write this number in scientific notation. The first part would be 3.58. So again, notice we have one non-zero digit to the left of the decimal point. This is going to be times 10 to some power. To determine the exponent on the 10, that is the power, we take the decimal point from its original location, which would be here, and we count how far we have to move it to get it right there, which is where it is in the final answer. So 1, 2, 3, 4, 5, 6, 7 places. So this would be 3.58 times 10 to the 7th power. That is the scientific notation equivalent of 35,800,000. Any questions on that particular answer? All right, let's look at some more examples of that. Let's say I have 1,300. To write that in scientific notation, that would be 1.3 times 10 to the 1, 2, 3, third power. Any questions on that example? All right, here's another example. 12. Scientific notation, 1.2 times 10 to the 1 power. And I suppose one could argue that that 1 as an exponent is not necessary, since when there's no exponent, a 1 is implied. Let's see. 42,300. So that would be 4.23 times 10 to the 1, 2, 3, 4th power. So these are all scientific notation. Any question about those examples? All right, now, in each of these cases, we took a large number, such as 35,800,000, and we wrote it as a very small number times a very large power of 10. We took a large number, wrote it as a very small number times a large power of 10, et cetera, et cetera. Now, let's look at some problems that kind of go the other direction. Let's say we had this problem, for instance, 0.00043. And we want to write this number in scientific notation. Well, the first part would be 4.3, okay, times 10 to some power. Once again, I'm going to move the decimal point from its original location to where it needs to be in scientific power, scientific notation. 1, 2, 3, 4 places, but I moved it 4 places to the right. So the exponent becomes -4. So this is 4.3 times 10 to the -4 power. So when we move the decimal point to the right to make it into scientific notation, we still count the number of places we move it, but the exponent is negative. Consider this. I have a very, very small number. I made it larger. So to bring it down to size, I need to multiply it by something small. 10 to the -4 power is certainly small, because 10 to the -4 power would be 1 over 10 to the 4th, which would be 1/10,000th. So we're taking something small, making it larger to turn it into scientific notation, multiply it by something smaller to bring it back to being equal to what we started with. All right, let's take a look at some more examples of moving the decimal point to the right. 0.086. Writing that in scientific notation, it would be 8.6 times 10 to the 1, 2, -2 power. Usually people get down the idea of, moving the decimal point, or how far you move it, it reflects the exponent, but they aren't real comfortable with the sign. Is it positive or negative exponent? Again, you've got to end up with something equivalent to what you started with. Here, I took a small number, made it larger, so I have to bring it back down by multiplying it by a negative power of 10, which is a small number. Any questions? All right. How about this example? 0.0000031. Let's see. Hang on. 314. Okay. So to write that in scientific notation, we would have 3.14 times 10 to the 1, 2, 3, 4, 5, 6, 7. So -7 power. That's scientific notation. All right. Are we okay with that? So that's taking a regular number, whether it's very, very large or very, very small, and converting it into scientific notation. Now let's take a look at some numbers that are in scientific notation and convert them to regular numbers, to whole numbers or decimal numbers. All right. Let's say we have the following. 2.87 times 10 to the 3rd power. All right, so multiplying by 10, just taking a number times 10 moves it 1 place to the right. Multiplying it by 10 times 10, or 10 squared, moves it 2 places to the right. Multiplying it by 10 times 10 times 10, or 10 cubed, would move it 3 places to the right. So what are we going to do? We're going to have 2.87. We're going to move it 1, 2, 3 places to the right. So we're going to get that. There is no power of 10. We used it up, moving the decimal point. Let's say I'm not real confident I've done it correctly. How could I check my work? Well, let's go back the other direction. Let's move this into scientific notation. 1, 2, 3. Voila, there you go. So there's the answer in terms of a whole number. Any questions about that example? All right, let's see here. 9.2 times 10 to the 6th power. Writing that as a whole number, it would be, let's see, 9, 2. I'm going to add a bunch of zeros here. Let's see, 1, 2, 3, 4, 5, 6. So I didn't need that last zero. So 9, 2, 0, 0, 0, 0, 0. Let's see, 1, 2, 3, 4, 5, 6. Yep. So there we go. So 9.2 times 10 to the 6th power is 9,200,000. Any questions about that example? Right. What about this one? 4.86 times 10 to the negative 2 power. So now, if we were to write this problem getting rid of the negative exponent, and I'm not suggesting we ultimately have to do this, it would be like that, which could be written like that. Now, I only bring this up to mention the following. Dividing by 100 would move the decimal point 2 places to the left. So multiplying by 10 to the negative 2 would move the decimal point 1, 2 places to the left. So I get 0.0486. That's my decimal number equivalent to the scientific notation here. Any questions on that? Okay. Let's see. 4.9 times 10 to the negative 7th power. Write this as a whole number or a decimal number. Since it's 10 to the negative 7 power, we're going to go to the left with a decimal point. I'm just going to add a bunch. Let's see, 1, 2, 3, 4, 5, 6, 7. So 0.000000, 1, 2, 3, 4, 5, 6, 4, 9. And there you have that. Any questions about that problem? All right. Take a look at the following. Let's say we've got, oh, hang on here just a second. I'll get something. 8 times 10 to the 4th power. 86 times 10 to the 3rd power. 8.6 times 10 to the 4th power. 0.086 times 10 to the 3rd power. Okay. Which of these are in scientific notation? Any of them, or is there more than one of them? What is it? No response today? Okay, it would be this one. All right. Some people might argue and say, well, what about that one? Well, I guess true scientific form, you'd write it like that. Okay. Let's see here. (48.6) times 10 to the 8th power. Is this number in scientific notation or not? Not, because there's more than one non-zero digit to the left of the decimal point. Okay, How about this one? Is that in scientific notation? Yes, it is, because there's one non-zero digit to the left of the decimal place or decimal point times a power of 10. Well, that's all I have for today. It's kind of a short section. Tomorrow we'll explore some more scientific notation, but that's it for today. So I'm going to go ahead and stop the recording